Hey there, students. Welcome to Psych 652 Lab, Module 10, where we'll be discussing hierarchical regression. All right, so our objective today is I'm going to give you a really quick overview of hierarchical regression. It's going to be really short. Kevin in the lecture, I'm sure, did a great job of explaining it all. And then we're going to go straight into coding. So what is hierarchical regression? Well, it's a way to show if variables explain a statistically significant amount of variance in our dependent variable. In reality, what's going on is that every time we add a variable into our model, so going from some sort of reduced model to an overall full model, you're going to see an increase in your R-squared value. But we want to know whether that increase in our R-squared value is statistically significant or not. So today we're going to be building one variable at a time to make a full model. We're going to be adding one variable at a time to a series of models and seeing if we are explaining more variance in our dependent variable from a statistical significance standpoint. So we're going to start off with a smaller model, a simple linear regression, and keep adding on to that model one variable at a time until we get to this bigger model. And then we're going to say what variables are we adding that are adding a statistically significant more explanation in our outcome variable. Which one is explaining more variance in our outcome variable, which is what that R-squared value is. So let's go ahead and get straight on to coding today. Okay, so per usual, we're going to go and open up our RStudio. We're going to go and create that new project, the new directory, new project. Make sure it's saved in the correct subdirectory, and this is going to be named module_10. Go ahead and create that project. Perfect. And then let's go ahead and download our data. So today's data will be in the Module 10 lab folder. So we'll go ahead and go down to Module 10. Okay, and it's the sleepesteem.csv data. So go ahead and use that. Open it up. Do File, Save As, Browse. Go to our desktop. Psych 652, Module 10, and go ahead and save it as sleepesteem. All right, so yep, looks like it's saved in there, which is great. Let's go and create a new R notebook. Okay, so we'll go and delete all this unnecessary text. Let's go and name this notebook Hierarchical Regression. And let's go ahead and create that table of contents that we like so much. DOC:yes. Okay, so the first thing we're going to do is load libraries. So we're going to be using 3 different libraries today, actually. So the libraries we're going to be using are the library tidyverse, library psych, and library OLSRR, which is that one that just helped to make better visual displays of a regression output. Okay, so we'll go and load that up. It's loading a tidyverse. Okay, perfect. All right, I'm just going to go and play that again to get rid of this output. Perfect, so it all loaded in correctly. So let's now go ahead and read in our data. So we'll be using that sleepesteem data set today. So let's go ahead and just name it SLP for short. Use the assignment operator. Use read_CSV. In parentheses, sleep steam .csv. Make sure it matches what this is here. And go ahead and press play. All right, we got a new object in here called sleep with 11 variables and 600 observations. And let's go ahead and actually, I forgot to do this earlier, but let's go ahead and save our notebook now. So we'll go ahead and name this module 10 notebook. All right. Okay, now we've got that saved. We can go ahead and go about describing the data. So insert, new R chunk, because it's always good to describe your data and just get a feel for what your data looks like. Describe sleep. Okay, so these are all of our variables all summed up. Nothing seems unusual here. It looks good. So what we're going to be doing today is we're going to be building a model where life satisfaction is always going to be our outcome variable. And what we're going to start off with is doing a simple linear regression and adding one variable at a time to these models until we get to kind of where we exceed a stopping point and say, all right, this is our full model. And then we're going to first be looking at the R-squared values and seeing how they change and see how they constantly go up and up by a certain amount every single time. However, we want to be able to compare that from a statistical point as well to see if it's statistically significant. And at the very end, we're going to compare all of our models together to see, are we explaining a significantly more amount in our outcome variable, that R-squared value, using these models. So it'll make more sense as we go on. But let's go ahead and start a new header. We're going to name this hierarchical regression practice. And we're going to do these things called building reduced models. So let's go ahead and do build. Let's make a second level header. Then we're going to do build reduced model A. And reduced model A is going to be a simple linear regression. So it's going to be, we're going to name this mod red A. Let's go and do capital A for that. Mod red A. And then it's going to be mod red A, use an assignment operator. And we do LM for linear regression. We're going to build a simple linear regression. So it's going to be life sat regressed on hygiene. And then do data equals SLP. So life satisfaction regressed on sleep hygiene. And then we'll go ahead and display those results using the OLS regress mod red A. Using the mod OLS regress function to display the results. Go and press play, and there we go. Looks like it's saying. So it's loading up. And while it's loading up, we can take a look at the R-squared value, because that's really going to be our main focus today. We're actually not going to be looking at the intercepts or slopes at all, but we can see that our model explains 25.5% of the variance in life satisfaction. So hygiene explains 25.5% of the variance in life satisfaction. Like I said, we're mostly just focusing on the R-squared values today. If you are running a regression output, you definitely want to be looking at these beta values and everything else in your model significance, but we're just going to be focusing on these R-squared and seeing how it changes. So we're going to build another reduced model, but it's going to be a slightly larger model. And this model, this time, is we're going to go ahead and add age to it this time. So we're going to go ahead and do ## build reduced model E. Okay, so go ahead and insert a new R chunk. We're going to name this mod _ reduce capital B. And then use our assignment operator. And then we're going to go ahead and regress life sat. We want to use our LM function. And we're going to regress life sat onto hygiene and age, comma, data equals SLP. Then we'll use our OLS regress function to display the model output. This is going to be mod red E. And assuming everything is spelled right there, it should be good. There we go. So while this is loading up, we can again look at our R-squared value here and see that it's 3.363. So now our newest model is explaining 36.3% of the variance in life satisfaction. Notice how again it went up from that 25.5% that we saw earlier. So now we're going to go ahead and build, reduced model C. Go ahead and create a new R chunk. And again, notice I'm just going to be adding one variable at a time. So this is going to be called mod red C. Use our assignment operator. This is going to be LM life sat regressed on hygiene plus age, and our new variable is going to be sleep efficiency. So sleep, comma, data equals SLP. So we go ahead and use our OLS _ regress on that. Mod red C. All right, and then we'll go ahead and get a new outputted model. There we go. So now we're explaining 49.5% as compared to before, which was 36.3% now. So now we're starting to question, okay, this looks like it's explaining a lot more. I mean, that's about a over 10% difference, right? That's about a 13% difference in explained variance. So it seems like a lot. So we'll find out later, is this statistically significantly more? But we still have to build all of our models. And then we're going to go ahead and build one more model, okay? So let's go ahead and this is going to be called our full model. So this is going to be build full model. So this is where we're going to end it. Build full model. All right, so then we're going to name this one mod full, just so that we know. Oops, let me go ahead and create a new R chunk instead of writing in the white space here. Okay, so we're going to name this mod underscore full. We're going to do this sign on, and it's going to be LM. So this is going to be life stat regressed on. It's going to be hygiene plus age plus sleep, and we're going to add in one more variable, and it's going to be self underscore esteem. Okay, and then comma data equals SLP, and then we'll use the OLS underscore regress. See what's going on here. Why is it giving me the X? We'll use OLS regress mod underscore full. And I just want to see for one reason, see why it's giving me this X here. Okay, looks like it's all running fine. I don't know why that X is there, but we'll go ahead and run this. Oh, there's my problem. OLS regress with two S's. Go ahead and run this. There we go. And it looks like it's explaining 49.6% of the variance, whereas before we were explaining 49.5. So that's not very much that we're explaining. But now we're going to be able to test it and see which one is statistically significant here. So how are we going to be testing this now? So we have a total of 4 models, right? We have mod reduced A, which was just a simple linear regression. We have mod reduced B, which is a multiple regression with age and hygiene. We have mod reduced C, which is hygiene, age, and sleep. And then we have our full model, which is hygiene, age, sleep, and self-esteem. So what we're going to do now is compare all these models and say which ones are statistically significantly, which variables are we adding that is adding a statistically significant more amount of explanation in variance, explaining a significantly more variance in our outcome variable of life satisfaction. So let's go ahead and do that. So we're going to do hashtag compare reduced and full models. So we're going to go ahead and create a new R chunk. And the way that we do this in R is simply using this function called the ANOVA function. And all we're going to do is make sure we list our models from the least, which is our simple linear regression, to the most complex model. So the least complex to the most complex. And it's important that you make sure that they're ordered in this correct way, because what we're going to be doing is comparing model A to model B, and then model B to model C, and then model C to our full model. Okay? So we're going to start off with our least complex model, which is mod A. So mod underscore reduced A. Then we're going to do mod underscore reduced B. We're going to do, sorry that. Then we're going to do mod underscore reduced C. And then lastly, our mod underscore full. And that's all it takes. And what we're going to do is get a comparison of model A to model B to model C, and a comparison of model C to our model full, with significance tests as well. So we go ahead and press play here, and voila. Okay, so our first one is saying this is model 1. And essentially what we're saying is that it has a residual sum of squares of 373.91 and a degrees of freedom of 598. Then we're comparing model 2 to model 1 here. Here's where we're comparing model 2 to model 1 and saying, does model 2 explain a statistically significantly more of the variance in our outcome variable? So that's hygiene plus age. And it looks like yes. In scientific notation, we're saying yes, it really does. So it explains a lot more of the variance in our outcome variable. And then we can compare our model 3 to our model 2, so which is model C to model B. And we can say, is this one comparing is this explaining statistically significantly more variance in our outcome variable? And we conclude again, yes, it is explaining statistically significantly more variance in our outcome variable. Then we can go down to our last one, which is comparing model 4 to model 3, which is our full model to model C, and say, is this? And the answer for this one is no. So by adding self-esteem to our model, we're not explaining statistically significantly more variance in our outcome variable. So in reality, what this is telling us is saying, hey, you should have probably stopped here, and that model 3 is the most parsimonious model. And remember, that's a big part of regression, is that we want parsimony in our models. In other words, we want our models to be as simple as possible. There's no point in adding self-esteem here if it's going to not explain that much more in our outcome variable. So unless you have some sort of practical reason that you need to add self-esteem, it shouldn't be in your model. So in reality, we're saying model 3, which is model C, is probably our best model to be going with. And that's really all there is to hierarchical regression, really. It's just that comparing this to from our models. You can do this backwards as well. You can build from a higher model and go down and see if it's worth it to take out variables. But here we just did a forward way of looking at it, where we start off with our reduced model and built up to a more complex model. So go and press preview, and you have a nice looking notebook here with a lot of information. Okay, so for your assignment, you're going to go to the Canvas, and then go to Modules, and then go to Module 10. And here's the Module 10 lab activity. You're going to be using the BAC OBS dataset this time. Okay, well, that's about it for me. So thank you so much, everybody. Let me know if you have any questions in the lab.